back to Code. And so guys, I hope you all are taking care and having a lovely time and enjoying the videos that I'm posting for you. So back with another more lesson to explain you about each and everything that we're talking about operating system. So if you are new to my channel, please do like, share, subscribe to my channel. So in today's lesson, what we are going to discuss, we are going to discuss about the scheduling algorithm. That is the FCFS, first come first serve, SJF, shortest job first, RR, round robin, fourth priority, and the fifth is multiprocessor queuing. We are going to discuss that what are all these types of algorithm and how they work and what are the advantages and disadvantages of these algorithms. So guys, if you are new to my channel, please do like and subscribe to my channel. Already on my YouTube channel, I have posted content regarding C, C++, Java, Python, SQL, networking, operating system, and everything that is really useful for you. All you can get on my channel. That is also free of cost. So guys, say to like it, share, subscribe, and also share it with your friends so that everybody gets the content. So let's get started with the video without wasting any time. Talking about the very first thing, that is the algorithm that we are going to talk about, is the FCFS. So when I'm talking about the FCFS, as the name tells, first come first serve, like the person or the thing or the processor that is going to first come first, it will be served first, basically as we see in a queue. So we have a long queue. So what will happen in the queue, the person at the first starting will be asked to do that desired task and need to complete that task, then only we will move to next person. So the first priority will be given to that desired first person. So what is FCFS? It is an important scheduling algorithm. It is non-primitive scheduling algorithm. In the CPU is allocated according to the process in arrival. Implementation is easily managed with the process in Fifo queue. Basically, Fifo is first in, first out. When a process enters the ready queue, its process control block is linked on the tail of the queue. When the CPU is free, it is allocated to the process at the head of the queue. The running process is then removed from the queue. So basically, FCFS what is follows the first come first serve basis. Now, what are the advantages and disadvantages? Coming to the advantages, it is simple to understand and easy to implement. It is suitable for batch systems. It follows principle of first come and first serve. No starvation, that is every process get served, because if in the queue all the things will be served accordingly. Now coming to the disadvantages of FCFS. Non-primitive, the process will run until it finishes. Like it is non-primitive, like it will keep on running until the process get finishes. We cannot move to the next process. Second, short processes have to wait for long processes at the front finish. Like suppose say whenever you are in a queue, suppose the very first person has a long list of documents to be submitted or any things to be done. So if we are having just a simple thing to do, then also we need to wait in the queue. So for the real world example, what you can see, like if you have to submit any documents, in that case, if you are in a bill queue, so first one is having a large slot of thing that he has purchased, so he has to stand in the first position and then only the other one. Then not suitable for time sharing system, may not yield best average response turnaround time. So these are some of the disadvantages when we are talking about the first come first serve algorithm. Now let's talk about the second algorithm that we have, is the shortest job first, basically SJF. So SJF is an algorithm in which process have the smallest execution time is chosen for the next execution. The scheduling method can be primitive or non-primitive. So it significantly reduces the average waiting time for the other process awaiting for execution. So basically there are two types of SJF. One is the non-primitive SJF and other is the primitive type SJF. So basically it is associated with each job as a unit time to complete. This algorithm is helpful for batch type processing where waiting for jobs is not very critical. It also helps to improve process throughput by making sure that the shorter jobs are executed first and possibly have a short turnaround time. So it also improves job output by offering shorter jobs which should be executed first, which mostly have a shorter turnaround time. So now coming to the advantages and disadvantages of SGF. First of all, the advantage is it guarantees minimal average waiting time because it services processes with smaller services with time before processes with larger services. Now we have a lot of short jobs, suppose say, so whenever these short jobs will be completed, we will be having a more time for the larger serving job. Disadvantages: the longer process may starve if processes without shorter CPU burst time continue to arrive. Now we have a burst time present into it. Now if say that is a longer time, takes a longer time, so in that case what will happen, we will be not be able to execute the longer processes. So that is the major disadvantage when we are talking about SJF. Next type of algorithm that we have is the round robin. So basically what is the round robin process do? A fixed time is allotted to each process called quantum for execution. Once a process is executed for a given time period, that process is permitted and other process executes for the given time period. Context switching is used to save states. And the previously lesson I have already told you what do we mean by context switching. If you do know that, please let me know in the comment section. If you do not know that, please check at the top right corner the I button from where you can switch to the previous video and also know what we mean by context switching. So in round robin, what it will do, it will create a quantum for the execution. So once the process is executed with the given time period, it will process the other given time period. Now coming to the advantages and disadvantages. Number one, each process gets a fair share of the CPU and short process finish relatively quickly. Second, simplicity and freedom from starvation. The process will not starve it. Third, specifically designed for interacting time sharing system. So this is basically designed for interactive and time sharing system. Now coming to the disadvantages. If time quantum is too short or too long, performance will significantly be affected. Like if the time quantum we say it is really very short or very more, so obviously what it will affect? It will affect the performance. That is the main disadvantage of round robin scheduling, that is the priority scheduling. Now as the name tells, what the priority scheduling, priority for each process. So priority is assigned for each process. Process with same priority are executed in FCFS manner, basically first come first serve manner. Priority can be decided based upon the memory requirement, time requirement or any other resource requirement. Now when we will be talking about the priority things, so it will involve some of the other things also included in it. Basically it will hold some FCFS priorities also, and based upon some priority based upon their memory requirement and every other thing. So in the priority, what are the advantages? Good response for time for highest priority processes, and the disadvantage will be indefinite blocking for lower priority processes. So these are disadvantages whenever we are talking about priority scheduling. Next type of thing that we have is the multiprocessor scheduling. So whenever the multiprocessor scheduling, when what we talk about, when more than one process is there, it follows two approaches. So basically the two approaches we called as load sharing and critical section problem. So coming to the very first thing, that is what do you mean by load sharing? That is multiprocessor. What is the load sharing? So the load is distributed evenly across the processor, assuring that no process is ideal while work is available to it. Now basically what it will do, it will just share the load accordingly so that no processor is ideal while the work is done. Second, no centralized scheduler is required. The scheduling routine of the operating system run on the processor to select the next thread. Now it will not include any centralized schedulers that this process to be run after this. It will automatically select the next thread to be executed. Third, a global queue of ready thread is maintained. It can be organized and assessed using a priority based schemes, and that can consider execution history or anticipated processing demand. So basically all the global queue thread ready thread is maintained, which will include all the organized and the assessed priorities. Now we have various versions of loading process, which can be FCFS, number 2 smallest number of thread first, number 3 primitive smallest number of threads first. So basically according to the processes, it will choose the type of version it want to choose. That we involve in the multiprocessor scheduling is the critical section problem. So basically the process holding the resource for some time and the other process cannot demand, that is called as critical section. So what is a critical section? A critical section is a code segment that assess shared variables and has to be executed as a above section. It means in that group of cooperating process at a given point of time, only processes must be executed in critical section. Only one process will be executed in that critical section. If any other process also wants to execute in critical section, it must wait until the first one finishes. So that is the basically purpose of the critical section. As you can just see on the screen also, this is the way through which what do entry section, then the critical section, then exit the section, then the remainder section while the execution is to be true. Going to work with the critical section, so we also have some solution through which we can work in the critical section. Number one is mutual exclusion. Out of a group of cooperating processes, only one process can be in the critical section at a given point of time. That is called as mutual exclusion. Second, progress. If no process is in the critical section and one or more threads wants to execute their critical section, then any one of these threads must be allowed to get into that critical section. So based upon the progress of the process, we are going to move it. Third, bounding wait. After a process makes a request for getting into its critical section, there is a limit for how many other processes can get into that critical section before this process request is granted. So basically what will do, they will create a limit so that the processes they want to enter into a critical section, they can be granted the access, so that the after the limit is reached, it will not grant the access. Before that, it can grant that desired access. So guys, I hope you must be clear about the different types of algorithm that we have discussed over here: FCFS, SJF, RR, priority, and multiprocessor queuing, and we'll be able to clear with the help of the examples that I've shown to you, with images and also the clear description of it. So guys, if you like the content that approach, please do like it, share, subscribe to my channel. Thank you so much for watching. Keep smiling. See you in the next video. Till then, take care and have a lovely day.